today we are going to talk about function notation. So I know some of you guys have seen this at map tests and on FastBridge before, and you're like, Mr. Kim, what is this F parentheses X mean? It looks like very hard stuff. And that's what we're actually going to learn today. It's actually not hard. It makes it look harder than it actually is because, it shows up on a lot of calculus textbooks and, advanced math textbooks and all that stuff. But today we're going to learn what that means and I'm going to teach you how to use it. So I'm excited for today's lesson as well. So today we're going to talk about I can evaluate functions in function notation form. Okay, so pretty much we're just going to learn how to use it, what it represents, and we'll go on from there. All right, so previously we learned how to write linear functions in the form y equals mx plus b, right? So in 5.3 we talked about how to get functions from a table, from a graph. You find a slope, y-intercept, and boom, you have all your information. You go on from there, right? Excuse me. Another way you can write the function is using function notation. All right, so what is function notation? Function notation is the following: f of x. So we say it f of x. All right. So why is it called that? Well, it's this function, right, in terms of x. If it was in terms of y, it'd be f of y. But mainly we deal with x's because that's just how algebra works, right? So f of x is equal to, let's see if you guys recognize this one, mx plus b. Yeah, slope-intercept form. So instead of everything, the only thing we've changed is instead of writing y equals mx plus b, we have f of x equals mx plus b. So the notation f of x is another name for y. You can use whatever other letters than f to name a function. You may see g or h. Sometimes you'll see s, or sometimes you'll say d. Like you can use whatever letter it is. It's just in terms of f, and the reason why it's a far advanced reason, and that has to do with integrals, and you guys will get into that later in high school. So example number 1, evaluating a function. So evaluate f of x equals negative 4x plus 7 when x equals 2. So it's what you think it is. All I have to do is plug 2 in for x. Okay, so how we write this? Do you guys see another x in this problem? Yeah, right here, right? So here's how I write that. So I have f of 2, right? Because now instead of in terms of x, so anytime I see an x in this function, I'm going to substitute in with the 2. Why? Because I'm writing it in terms of 2 instead of x. So now f of 2 is equal to negative 4 times 2 plus 7. So if f of 2 is equal to negative 8 plus 7, f of 2 is equal to negative 1. And this is how we write it in function notation form. Okay? Here is the last example. I think this is it. It's a pretty short lesson. This last example we will do. Okay, solving for the independent variable. So it looks like for h of x equals 2/3 x minus 5. Find the value of x for which h of x equals negative 7. This one seems a little different, right? The other one I was given x equals 2, so that was easy. I just plugged it right in. But this one I can't just plug it in because it says h of x equals negative 7. Do you guys remember substitution from systems of equations, right? Do you guys remember how we solve with like y equals 2x plus 3 and like y equals 4x minus 5, right? How did I solve that? Didn't I just plug this in? Whoa, that was bad. Didn't I just plug this in right here, right? So I had 2x plus 3 equals 4x minus 5. You guys remember that, right? This is exactly the same thing. So let me I'll leave that here. So here's my first function, h of x equals 2/3 x minus 5, and here's my Second function, h of x is equal to -7. All I'm going to do, I'm going to plug -7 in for h of x, right? So that's it. So all I have to do is set those two equal each other. So -7 equals 2/3 x minus 5, right? And then now I solve for x. Why? Because it says to find the value of x. So if you end up solving for like y, that means I did something wrong. It says to find the value of x, right? How do I do that? U plus 5 plus 5 -2 equals 2/3 x. From here, you have a fraction, so you can multiply it by the reciprocal. Right, when I multiply it by the reciprocal, 1 I have over 1, so I have x to be equal to -3. Alright, so those are the two types of problems you guys will see. Examples on your own 1 and 2 are like example number 1, where you plug it in and you evaluate. And example 3 is where you have to use the quote-unquote substitution, or a different way of, it is substitution actually, so we'll leave it at that. Yeah, so finish those 4 examples and then submit your answers on Edpuzzle, and then fill out your level of understanding. And that is it for today's notes. Good luck.